Hello. So this video's purpose is to review what I study, and the purpose of this video is to improve my English and also explanation skills. Uh, so this is not like tutorials. So anyway, let's start. Uh, so first I'll go with I learned threads and multi-threading. So yeah, thread is a basic unit of CPU utilization, and they have those factors. Thread ID, program counter, register set, stack. And the difference between single and multi-threaded process is that single thread require uh, so these code data file register stack for each thread for one thread. But for multi-thread, uh, this code data file is shared. These resources shared with multiple threads. And those multiple threads, for each of them, they have registers, stack, registers, and stack. So this is heavyweight process. I believe that it's because this one thread require code data file register stack like these five factors. But for lightweight process, it requires one resource, code data files, and you can share that resource. So it makes the whole thing lighter. That's why it's light process. So yeah, benefit of multi-threads. So responsiveness. So even if a process has to leave, the threads uh, can still continue running. So this is the uh, one of the advantage. And resource sharing. As I said, several different threads can access same address space. Address space means like, yeah, code, data, and files, like these resource. And since they can share resources, the threads are much cheaper to initiate because it doesn't need to create many resources. Scalability, you can make as many threads as possible. So you can just create these threads as many as possible. So that was the benefit. Those were the benefits of multi-thread. Uh, Okay, difference between single core system and multi-core system. Single core system uses one processor, and multi-core system uses multiple processors, which makes process faster. Um, okay, I'll skip this one first, then go to many to one. Okay, so there's three multi-threading models. First one's many to one, second one's one to one, and third one is many to many model. So in many to one model, uh, multiple user thread enter tries to use the one kernel thread, which can be a problem. The disadvantage of many to one is that since there's several user thread and trying to enter one thread, it can block one thread can block other threads, so it takes longer time. One to one. One to one, each thread goes to uses one kernel. So the advantage is that it overcomes the disadvantage of many to one. Since each thread is taken care of by one by many kernel threads. How to no? I think that's not right. Since since one thread is taken care of by one kernel thread, it doesn't cause the blocking because no other threads are coming to one kernel, but one thread is coming to one kernel, so it doesn't block. But the disadvantage is there's a limit with number of threads that can run, so it cannot create that many kernel threads. This is the problem. In many-to-many model, it overcomes the problem one-to-one and many-to-one. So basically what's happening here is several threads are going to several kernel threads. But the difference between one-to-one and many-to-one is that one kernel is not taken care by one kernel. Several user threads are taken care of by several kernel threads. And it doesn't block too. It doesn't have a limit of user threads. And also it doesn't block because even one user thread is using a kernel. It has other places that user thread can use. It has other kernel thread. No, let's say even it doesn't cause the blocking problem because if one user's thread is using one of the kernel, there's still other kernel that can take care of other users' thread. So it doesn't cause the blocking. That is the advantage of many-to-many model. And I couldn't really find the disadvantage of this. So let's go back to here. User level user thread. User thread is supported above kernel and managed without kernel support. So it doesn't require kernel support. So it's done by here. That is the user thread. And kernel level supported and managed by directly by operating system. So it is this phase, this place. What is that line indicate? I think this is the line. Like, what does this mean? So it is created in a application level, but it still requires kernel. It needs support from kernel space too. So this line reaching this space means that this thread requires kernel space support. And the thing about kernel thread is that kernel level threads are slower than user level threads. So in user level thread, it uses something called local call, which doesn't require operating system to interfere when threads are communicating each other. Whereas in kernel level threads, it is called system call, and it requires what was it? All right. So when system call is used, it uses system call of PCB. So when PCB get updated, like there's gonna be additional process required, so which is taking longer time to process. Okay, finally, the difference between user level threads and kernel level threads. So managed by user level library, managed by OS. So as I said, it requires the support from OS. That's the kernel level threads. And fast and relatively slower. This is because of PCB needs to be updated on this section, kernel level threads. This is a system call and this is a local call. And context switching is faster, relatively slower. This is also a same reason, because PCB needs to be updated when context switching occur. So in local call, it doesn't require that, but it requires on kernel level threads. That is why. So I did a review of multi-thread this time. So that was it.